Okay, 6.5, solving radical equations.
Carlos Zambrano, please report to the office immediately. Carlos Zambrano to the office, please.
Okay, so in these examples, you are trying to isolate. So you're just trying to work with your algebraic skills, making sure the order of your algebraic skills are in the right order. So to isolate this, the first thing I need to get rid of is the division by 3. So if I multiply both sides by 3, that's gone. 4 root x plus 7 equals 27. Now I would get rid of the 7. So 4 root x equals 20. Now I have to get rid of the divide, or the times by 4, so I divide. And then my last step, to get rid of a radical, I do the opposite function. So that's square, and then I get x to be 25. Okay? When you're done these, you have to check your solutions. So this, plugging in root 25 is 5. 5 times 4 is 20. 27 divided by 3 is 9. So it checks out. Okay? Example 2. Okay, so in this example, first thing I'm going to get rid of is the division by 5. So times both sides by 5. I get root 4x plus 1 equals 25. Now everything in here is under the radical, so I have to actually get rid of the radical next. Versus here, do you see I go and get rid of that because it's separated from the radical. So if I square both sides, that cancels and I get what's under the root and 625. Now I can get rid of the 1 and then I can divide by 4. Okay, check your answer when you're done. 4 times 156 is 624 plus 1, 25. The square root of that is 25. 25 divided by 5 is 5. Works. Okay, let's check out another one. Root x plus 3 plus 9 equals 5. Okay, so we're going to subtract 9. Okay, so when you get to this point, there's going to be no solution. Okay, and here is the big idea why. If I tell you x equals 5, and then we square both sides, and then I square root it, I could get x to be x could be plus 5 or negative 5. So all of a sudden, can you see mathematically my steps are legit, but I've created myself an extra solution. Okay? So for instance, if we do solve this by squaring both sides, okay, I would get this to cancel. I'd get x plus 3 equals 16. So therefore x would be 13. When you plug 13 in, you get the square root of 16, which is 4. 4 plus 9 does not equal 5. Okay, so we can't have these roots equaling a negative number because in order for it to equal a negative number, you would have to have a negative out front. So if I have this, okay, this solution is 5. If you wanted a negative 5, you would have to imply the negative out front. Okay, another example. Root 3x plus 1 equals root 4x minus 7. So we can square to get rid of the radical. Same thing on both sides. Okay, once you do one thing to one, you do it the other. And in both cases, the radicals cancel. And that's what we get. And to algebraically isolate, I would get rid of the 3x. Get the 7 to that side. And get 8. I'm going to check my answer. 3 times 8 is 24 plus 1 is 25. Root 25 is 5. 32 minus 7 is 25. The square root is 5. This works out. Okay, last example. Root 5x plus 14 and then plus 2 equals x. Okay, so I want to isolate this root, so I'm going to move the 2 to the other side. So x minus 2. Okay, and then to get rid of this radical, I'm going to square. But here's the trick. When I square this side, it's a binomial squared. So these cancel. But this really becomes that. So don't forget that you have a whole system of FOIL. So x squared, I'm going to short this with an outside inside. Minus 2x doubles. And then plus 4 is your last. We learned this in Unit 1. Remember the relationship? This doubles, this squares. Now I'm going to move these to that side. So I'm going to take off 5x, take away 14. 0 equals x squared minus 9x minus 10. Once I'm here, I can't isolate it, so I need to factor. X, I'm going to use a 1 and a 10. Negative, positive. So x could be negative 1 or x could be 10. When you plug it in with your solutions and you plug in 10, that's 50, 64. The square root is 8. 8 plus 2 is 10. That checks. Negative 1, you get 9. The square root of 9 is 3. Plus 2 is 5. 5 does not equal. So you have one solution.